So today, the last thing that we are going to look at this semester is being able to simplify our quadratic formula when we are dealing with an irrational solution. So yesterday we talked about using this quadratic formula, but every answer that we had was either a perfect number or we were able to write it as a fraction, right? Those are your rational values, right? You're able to record your answer as a fraction there. Okay, so now when we're dealing with the irrational solutions, an irrational number is, there is no ratio for it, right? There's no fraction that we can record for the value. So actually, it kind of makes life a little bit easier for us. So let's get into some examples here. So for example, I see here with our quadratic, we've got a 5x squared plus 5x minus 1. Again, just kind of getting you into the habit of being able to recognize that A, B, and C value. I kind of already have the template for the quadratic formula in there. So all I'm going to do is pop in those A, B, and C values. Again, definitely have the quadratic formula handy next to you. You don't have to memorize this, okay? So here we go. So x is equal to the negative b value. My b value is 5, plus or minus the square root of b squared, which my b value, again, was a 5, minus 4 times a. My a value is a 5, times c. C is a negative 1, and all being divided by 2 times a, and again, the a value was a 5. Okay, so nothing different, and the next step, again, it's not going to be anything different here, okay? So once we get everything into our numbers or into the formula, the first thing that we should do is simplify the stuff underneath the square root there, okay? So the stuff underneath the square root, I have a parenthesis 5 squared minus 4 parenthesis 5 parenthesis negative 1. Okay, so again, parentheses are definitely important here. You will screw it up if we don't use our parentheses. Okay, so word for word as we see it there, once we hit enter, it gives me a 45. Okay, so now what I'm going to do is rewrite what I have here, but instead of seeing all of that stuff underneath the square root, I'm going to put the 45 that we just found it to be. And again, I'm going to kind of jump another step. I'm going to go ahead and take care of what 2 times 5 is and what this negative 5 is. All right, so the negative times the 5 is a negative 5. Plus or minus the square root of 45. Right, all of that stuff that was underneath the radical that we just figured out to simplify to be 45. And again, I'm going to go ahead and take care of that 2 times 5 and just say 10. Okay, well, yesterday we looked at, once we got to this point, we were able to take the square root of that value, right? We looked at our perfect squares. We did an example with a 0. We did an example with 100. All of those had our, what we call a perfect square. Now we're dealing with the 45. So here was the list of values I gave you the other day of what you can take the square root of. So the square root of 45, and these are in order, would be somewhere in between 36 and 49 here, right? Notice 45 is not a perfect square. There is not a number we can multiply by itself that will get us a 45, okay? Because, 6 squared takes us a 36, and 7 squared takes us a 49. So the square root of 45 is going to be somewhere in the middle of that, right? And if we put that in our calculator, right, it's going to give us an irrational number. Second square root of 45. Look how many decimals are there. Okay, and your calculator stops it. There's an infinite amount more decimal places than what you see. Okay, your calculator just can't give you an infinite amount of numbers there, so it just has to stop at some point. And again, irrational numbers cannot be written as a fraction. Look what happens when I try to put it as a fraction. It's just going to give us the same exact decimal. Okay, so these numbers are referred to as irrational solutions. You cannot write them down. Okay, so the way we're going to treat this is, like I said, it's going to make life easier for us. We're just going to leave it alone, okay? There's nothing else that we can do about this. We're just going to leave the square root of 45 as the square root of 45, okay? Now, when you get into delta math, I think it does ask you to write it like this, but understand that there are still 2 answers here, okay? So we still have a positive case. So x is equal to negative 5 plus the square root of 45 over 10. And you still have the negative case, okay? X is equal to negative 5 minus the square root of 45 over 10. Okay, so you still have two answers there, but instead of, an answer just being, 10 or -1/2, okay, we've kind of got this big answer left with us, okay? And it's all because the square root of 45 is an irrational number. We cannot condense it any further, okay? So I'm just going to do one more example here. You did a lot of examples with this stuff doing rational solutions. I don't feel like this is too big of a step moving forward. Biggest thing also to remember, it's got to be set equal to a 0. I know the two examples I just gave you were that way, but you need to make sure it is in standard form. This guy is, so now we're able to recognize or identify A, B, and C. Remember, A is next to x squared, B is next to x, C is my constant. So let's go ahead and fill those guys in. So this is a negative B plus or minus the square root of B squared, which is 2. Minus 4 times A times C. Okay, so it's just kind of a plug and chug here. So now that I've got my A, B, and C values inserted into my quadratic formula, okay, we are just going to simplify it like we have been doing for the past couple of days, okay? The first thing that we look to simplify is all of that junk underneath the square root, okay? So again, using your parentheses word for word, as you see it written, parentheses 2 squared minus 4, parentheses 2, parentheses negative 18. Okay, and we're going to hit enter. That gives me a 148. Always check to see, throw in your calculator, see if this is a perfect square or not. We can say second square root of 148. Look how it gave us that non-terminating decimal again, right? This is your irrational value. And again, the square root of 148. Here are the values I gave you that are perfect squares. 148, well, we went from 144 to 169, right? And which makes sense why our decimal is just a little bit past 12, right? So 148 is a little bit bigger than 144. Okay, there is no perfect value for that, okay? So again, we need to simplify this a little bit further. Okay. X is equal to, we've got a negative 2 plus or minus the square root of, like we just found, all of that stuff underneath the square root took us to 148, all being divided by a 4. Right, we've got 2 times 2 there. And like we just talked about, that square root of 148 cannot go any further. So all I'm going to do is just kind of separate our two cases here. We've got the positive case. X is equal to negative 2 plus or minus the square root of 148, all divided by 4. And we have the negative case. Right, we've got the negative case with the minus. X is equal to negative 2 plus or minus the square root of 1. Oh, not, what am I doing, plus or minus? Sorry. I separate the cases. There's no plus there. My bad. There's no minus here. So the first case, negative 2 plus the square root of 148 over 4. In the second case, we have the minus square root of 148 over 4. Again, I don't care how you write it. Both are the same exact things. Whether you put the pluses and minus together and just write it once, or you separate the two cases and say one case is a plus, one case is a minus. Understand that they are, the exact same thing. I don't know how Delta Math asks for you to write it. I think they're going to ask you to keep it as kind of one answer there, using the plus and the minus. But do understand that, just because we can't break that down, there are still two answers here. You still have the plus and the minus case. Okay, so those are two examples with your irrational solutions. More or less just kind of getting you more practice with the quadratic formula, identifying that A, B, and C value, and being able to simplify. Again, always reach out if you are still stuck, or if you need more examples, or if you need help on your Delta Math assignment there.